So let's look at the properties of a rational function today. When we talk about properties, we're looking at a couple of things. We're looking at domain. We're looking at range. We're looking at the variation. And we're looking at the sign. So these are the four main properties that we're going to be looking at. Obviously, the zero and the initial values are properties as well, but I've covered those already in separate videos. So when we look at a domain of a function, we're looking to see how far does it spread along the x-axis. So along the x-axis. Now, remember, when we look at a rational function, and I'll just draw a little tiny graph right here. Let's say that this is my function here, and it's curving like that. This point here, that is your h and k, and that basically tells you where the divisions are. Now, there are two parts to this function. There's the left side, and then there's the right side. And so when we do our domain, we have to look at what our left side is first, and then what our right side is. So the domain for any rational function will be given as negative infinity to h. Now, because h is our asymptote, it does not actually exist as part of the function, so our bracket must be facing away, just like with the infinity. So this set describes the left side of our rational function. Now we want to put a little u here, that's our union, that basically joins the left side and the right side, and it also tells us that there's a change in the function here, there's a bit of a gap. Then we look at the right side. So again, it starts at h, but our bracket must face away from our h because it does not include h, and then it goes all the way to positive infinity. So the domain for any rational function will be this. If we look at our range, the range is when we're looking at how far does it spread in the y-axis, so how tall is our function. And similar to with the domain, it's going to have the same form. We're going to have the bottom and the top, and we always look at the bottom first. Now the bottom will always start from negative infinity, unless of course there is a constraint. And then it will reach until k, until we reach our k value. Now again, k is an asymptote, so we have to have our brackets facing out. Then we put our little u for the union, and then we open bracket again facing away from the k. That's where we're going to start for the top portion, all the way to positive infinity. So this is what we would put in for our range. So these two properties are pretty straightforward. Now, variation and sign are a little bit more tricky to look at. So I have a couple of tricks for you. Let's take a look at variation first. So variation means change. And what we're looking at is we're looking at the change in y as we increase in our x. So as we increase in our x values, what is our y value doing? So what is the change in our y? Now, if the x and y values both increase, then the function is increasing. is increasing. Let's use proper grammar here. Now, this is pretty straightforward. But if we have our x and y values where they're doing the opposite, if our y values are decreasing, then the function will be decreasing. If the y values are decreasing, oh man, I can't spell today. If the y values are decreasing, then the function is decreasing. Now remember, we're always looking from left to right when we're reading this, like we do when we read a book. So once you have got this sorted out in your head, then it's pretty easy to see if a function is increasing or decreasing. Now if we look at this sketch here, if we start from the left, we can see that the y values, as we increase our x values, are decreasing. And the same goes for this part here. So this function is in fact decreasing. Now, when we talk about variation and sign, we also want to look at the interval over which it is decreasing. So for the rational function, your variation is pretty much going to occur over your domain. So these two, the variation and the domain, go hand in hand right here. So if you ever get the question asking, what is the interval which your function is increasing or decreasing, then you need to give them the domain. Now this is just for the standard form that we've been using for the rational function. Obviously there are different types of rational functions. We're using just the standard one. So this would not work for all of the different types of rational functions. But for this class, this is relevant. This is what it's going to do. Now the sign is a little bit different. The sign is whether it's positive or negative. And to do that, we have to look at, for each x value, what is the sign of our y value? So positive or negative. So like, say if we were looking at this function right here, and let's choose a different color just so that we know. Yeah, sure. Let's go with that. So let's say we were looking at this color right here, this point right here. If we look at this x value and we move up to where the function is, we see that the positive y exists with this negative x here. Now if we moved over here, we can see that it's still positive. However, if we moved over to this side, we would see that we have a negative. And the negative happens to cross over at, looks like the origin right here. So when you're looking at the sign, you need to look at where does it cross the x-axis. And from there you can determine your intervals where your function is positive or negative. So let's take a look at an example. Let's open let's take a look at this example right here. Okay, so let's choose a different color just for fun, and let's decrease the size of this for a bit. So let's take a look at our domain first. Now, we know that our domain will always start with negative infinity with this, and when it goes towards our h. If we look at our h here, our h is +1, our k is +2. So the domain goes from negative infinity to 1, open that bracket, open that bracket again, and then it goes from +1 to +infinity. So this is our domain of this function. Now let's look at our range. So same form, except instead of the h, we're going to be putting in our k. So we have negative infinity to +2, right? It starts from negative infinity, it goes all the way up to +2. Doesn't touch it though. Then it starts again at +2 and goes all the way up to +infinity. Now, let's take a look at the variation. So let's write that here. Variation. Now remember, the variation occurs over your domain. So let's put in our domain right away. Now we need to determine if it's increasing or decreasing. So we start from the left, move along the x-axis, and see what's happening with our y value. So as we move this way, what's happening with our y values? And we can see that the y values are decreasing. So the function is decreasing over the following interval, which is your domain. Now, let's take a look at our sign here. So let's just say that on this side here, so let's take a look at our sign. We have positive and we have negative. So we can see that as we move here along this line here, up until it crosses right here, this is all positive. So this section is positive. And if we look at this side here from this asymptote onwards, we can see that this is positive as well. Now let's take a look at this little section right here, in between your asymptote and the 0 of the function. This is where it starts to become negative. So let's take a look at how we would write that. So we have positive over the following two intervals. It goes from negative infinity. We always read along the x. That's why I've highlighted the x. So it goes from negative infinity to, let's say it's negative 0.5. Close that bracket. And then we start up on this side here. Now it starts at the asymptote, so the asymptote must be facing out. Starts at +1 and keeps going all the way to +infinity. And that is our positive part. Now, this function is also negative, and it is negative over this tiny little interval right here. So it's negative from negative 0.5 all the way to our asymptote, which is +1. Those are the properties of a rational function. Thank you for tuning in, and I will see you when we start talking about the exponential function.